All right, it
It
looks
looks
like
like
I
I
got bumped.
bumped. It looks like I got bumped. So let me try to get back to where I was. Okay. So can everybody see my pumps? All right. So we're back on stream, but it looked then that means there will be two recordings for this meeting. Okay. So as I was saying, the size of these pipes sometimes it's not practical to actually have them inside the walls of buildings either. Okay. Once the water leaves the treatment plant, then it goes through another set of large pipes, which has that's our treated water transmission lines. Then that goes to our distribution mains and then to service lines, which connects the service lines connect our customers. So what generally happens, our transmission lines are usually larger sized pipes than our distribution mains and our service lines. As we go closer to our consumers, the size of our pipes tend to drop. Okay, so the size of our pipes tend to drop as we head closer and closer to our consumers. Okay, so transmission lines are larger, whether it's raw or treated water, these lines are larger. Then we have distribution mains and then service lines. Okay, so let's move to the next item. So if I scroll down, you see some of the things that I mentioned earlier. Okay, corrosion resistance, smoothness of the interior of the pipe, which is where we consider the C factor of the pipe, compatibility with external and local conditions. Okay, that's where we're looking at um, the water, the pH of the water, for instance, can cause corrosion in some pipes. We look at the accumulation of most times calcium chemicals on the inside of the pipe based on what's in the water. Then the external, we look at the soil, we look at traffic, the pressure of traffic, how deep this thing is to be buried in the soil. In places where we have snow or freezing, then there are considerations that have to be given with regards to that. But we are going to look at that a bit later because usually we want to put the pipes at a certain level in the soil so that they will not freeze easily. So let's look at pumps. Okay, some person asked in the chat about what happened earlier. Um, I'm the host for the meeting and I got cut off. So everybody got cut off and I just restarted the meeting. So everybody has to try to rejoin. I posted something in the WhatsApp group, I think. So let me tell people, please rejoin. Okay. All right, somebody has a question. Gavin, you have a question? Go ahead, ask. Gavin, I'm waiting for you. Should water temperature, he's asking, should water temperature be taken into consideration? Now, in I think our first class, when we looked at some of the properties of water that are considered, and we did mention temperature, but we said that it was an aesthetic quality of the water. So it's not as important as the quality of the water in terms of microbial quality or other chemicals in the water that could cause harm to our customers. But temperature, in some instances, it is considered. Okay. However, the distribution system does not have a lot of control over the temperature of the water that is received because we have pipes all over the place. We have a network of pipes under the ground, and it is difficult to control that temperature. Having said that, though, when we consider the thermal qualities of soil, if the pipe is buried at a certain depth in the soil, the temperature of the water tends to remain constant because of the thermal qualities of soil. Okay, so I'm not sure if that answers your question. I also wonder whether you were asking in terms of freezing, because in situations where our pipes are in places where we have issues with freezing, there are systems for handling thawing, making sure that the pipes do not freeze over. There are systems that involve conducting electrical currents through it. There are various systems that take care of that as well. So I hope this answers your question. Any other questions so far? Okay. So pumps. There are several types of pumps. You need to be aware of the types, but for the most part, centrifugal pumps are the pumps that are used in most places in the distribution system. In wells where we use groundwater, very often we use the vertical turbine pumps. I used in groundwater systems a lot. Displacement pumps, these pumps are generally used in the treatment plant to pump fluids, chemicals into the water as the water is being treated. So you will find these different ones in different locations, but above all, centrifugal pumps are the most common types of pumps. And they are the most common because they are generally very reliable. They are not generally affected by outside conditions, the pressure and so on. So they generally continue to work. And the way that they work, water generally comes in through the center and the center of a spinning part. The video actually discusses it in detail. And as the water comes in through the center, it's basically sent to the sides of that thing and then goes out. Okay, so we have is the spinning action that gives the water, that allows it to move the water. And the idea of centrifugal force, when you think of centrifugal force, you could think of, what's the name of that thing? That thing that children usually go on in these theme parks, entertainment parks. There's a roller coaster, right? Not quite a roller coaster, you know, almost a merry-go-round kind of. Imagine, imagine you are a father and you are spinning your child all around and around and around and around. Imagine what would happen if you let go of your child, or if it happens accidentally. God forbid, but if it happens accidentally, your child will fly off. Your child will not just fall right next to your foot or fall right where you were holding her, just fall down to the ground, but the child will actually fly off. You could try it with something attached to a string. You spin it, spin it, spin it, spin it, and once you drop the string, that what we call centrifugal motion, what it does is it sends objects, it sends the heavier objects further away, and the lighter objects stay closer to the center. So it basically sends the water off. Okay, it increases the velocity of the water and sends it off. Okay, so that's how they work essentially. Okay. Um, Somebody posted that they require very little maintenance, Gavin. That's a very good point. Um, and if you're choosing equipment, you want to choose the equipment that will give you several things. It is reliable, which means it will require little maintenance. If you buy something for money and you have to use it every day, and then you have to fix it every day, then that comes at a cost both of money in terms of having to change parts, paying a repair person, time, as well as the effects on the system. Because if we have pumps that are always going down, it means these pumps will not be available when they are needed. And that will affect our system, our ability to get water to our consumers. Okay, so we also have now purpose of pumps to move the system at usable pressures. Okay, to move the system at usable pressures. The video that's there also goes into other things that we use pumps for. But note, it moves the water and usable pressures. Okay, so we use it to help us maintain pressure a bit. Okay, so valves. This mentions several types of valves, and we have quite a few different types of valves that are available if you deal with piping and liquids, which includes water. We have a few different types of valves that are available, and we are going to choose valves based on what function is needed. Um, this section here mentions a few of them: gate valves, butterfly valves, check valves, control valves, and it tells you where they are used. Okay, so there are a few things that you need to know about each of these valves. Of course, you need to know the name, okay, but you need to know how it works. Okay, you need to have an idea of how it works. You need to have an idea of where we would use it. For instance, if we look at gate valve, okay, we use it to just start and stop water. Because what happens, this thing, this control here or actuator allows us to lower or to raise some like a plate, okay, in the bottom of the valve here. So it allows us to lower that plate or to raise it. So if we lower it to the very bottom, no water can pass through. But if we raise it, water can pass through. So this is one of the more simple valves that you will come across, a gate valve. So we use it basically to start and stop flow. So you might find these gate valves at points in the distribution system where we need to isolate these points. And we may need to isolate points in the distribution system for where we have to do repairs or additions. The placing of valves at various points allows us to close off just little sections instead of having to close off the entire system just to do a repair in the corner of town. Okay, so valves gives us that kind of flexibility, and the gate valves are one of those that allows us to do that. Let me go back up. So purposes of valves, so it gives us about 5 different things that we use valves for: start, stop flow, isolate piping, which I just mentioned, on-off service, which is related to that, but which can also be done, for instance, at meters. We have these valves that we use, and we could just close off service if persons have not paid, and we can lock it as well. Okay. To allow flow in one direction, here, check valve, or to relieve pressure, pressure relief valve. Now, these are here. So turn service on and off, butterfly valve, and we can use it for some what we call throttling. Okay. Check valves, we usually have them at points where we want to prevent what we call backflow. Okay. For instance, a good place where we would want to check valve is where we have, for instance, a tank. A consumer has a tank and we give them service. It's required that they have some kind of means of preventing backflow and what we call cross connection. Okay, very good, Ezekiel. So Ezekiel just made a point that sometimes the gate valves are used to regulate flow, which is not regulated, which is not recommended, sorry. And this causes the lifespan to shorten. Because of that gate that it has, it's not really meant to be used half open, half closed. It's not really meant to do that kind of stuff. So it's better if it's used for just start-stop applications. Somebody is asking how far apart valves should be installed. Now, that's not a question I believe you could just answer just so. Okay, it would depend on the system design and what you are actually trying to do, because you have different types of valves on the system. So it would be depend on the system design and what you're trying to do. Okay, if you're doing isolation, if you have the valve there for isolation, when you're designing your system, your engineers will determine what in a sense what blocks that you want to isolate. So it depends on how the thing is designed, Gregory. I cannot recall a standard rule for the location or like in terms of distances of valves. But I know that it has to do with the particular system design and the type of valve. I was saying that check valves we use where we use them, for instance, if somebody has storage, is storing water. It could be an industrial application or somebody who has a tank at their home. We would not want that water to get back into the distribution system. If that water gets back into the distribution system, we see that we have backflow because the water is flowing in the opposite direction. And we also say that we have a cross connection. Okay? A cross connection, these are connections where you're making a connection between the water system, our water distribution system, and a system that is independent. It could be an industrial place where they have tanks that have water. Sometimes in these industrial things, these tanks are also connected to other places, maybe pipes where chemicals are flowing. And we would not like there to be any chance of chemicals getting back into the distribution system, because in some of these industrial applications, the chemicals that are used are hazardous. So we must take measures to prevent that kind of backflow and cross connection from happening. Because if some of these chemicals end up in our water system, the health and in some instances the life of our consumers can be affected. Okay, so this is very serious. And there, according to the Safe Drinking Water Act, there are some things that are suggested to prevent cross connection. Two of them, two important ones, the check valve is one, but the air gap is the one that prevents any form of cross connection from happening, because there's a certain distance in terms of air distance between the part that allows water to come in from the distribution system and the system that the water is going to. Okay. Now we've had instances in the past where, for instance, there was an instance that I remember in the US where these guys were a pest control company, and they had a tank with pesticides in it, and they were using water to dilute the pesticides. But what they did, they had a hose connected, a hose coming from a pipe that went into that tank. So between the tank and the hose, there was no check valve. The end of the hose was dropped into the tank of chemicals. And then you had back siphonage, you had water basically flowing back into the hose. And that water ended up in the distribution system. Because at the same time they were doing that, some repairs were going on in the system that allowed the pressure in the system to drop. So you had back siphonage and the water just went, the chemical went into the system and many persons were affected. So we have to be very careful with these kinds of things. So an air gap is one of the forms that definitely does not allow any cross connection, because water generally does not flow in an upward direction. So we make gravity help us there. Okay. Any questions, concerns? We have 2 minutes left. So I want to take questions, concerns, discussions, reflections. I know we didn't get to storage, but while I wait for questions, I could just discuss storage while I wait for questions. Okay. There are several reasons why we want to have storage. Now, when persons think about storage tanks, most times all they're thinking about is to put water aside for future use. But in the distribution system, our storage tanks do much more than that. Okay? So we have about 3 main reasons, could say 4, why we need storage tanks in the system. The first one is firefighting. Okay, and you will realize firefighting comes in many times. So we must have both adequate pressure and adequate volume for firefighting. So even if the pressure is high and we have a little bit of water, the house will burn down. Okay, so we want to provide enough water pressure, but enough water as well, so the firefighters can do their thing. Okay, so fire flows must also not cause other problems in the distribution system, such as low pressures or no flows. For instance, if the firemen come right now, there's a house burning somewhere, God forbid, and the firemen show up, they attach their hoses to our valves, to our hydrants, and they start sending water on this house to out it. The fact that they are doing that should not mean that other persons in the distribution system do not have water because they are out in a fire. Okay? So that's what they're saying. We should have enough flows so that whilst they're doing that, it does not cause other problems in the distribution system. The second one is to provide water for peak periods and emergencies. So that's where we look at storage. That's another place. Firefighting storage as well, and pressure. But it also there for peak periods, because peak periods, these are periods where we have most of our consumers using the water system. So they are using water. Now, peak periods, usually this happens if you're in an industrial zone, then you'll have a peak period where we in business hours where things are being used. If you're in a residential zone, your peak periods might be in the morning and in the evening. So when people come from work and when people wake up in the morning, they're getting ready. So we want to make sure that our consumers can get the water at with reasonable pressure during these periods. So our storage provides for this. Also, when we have a dry spell and we are not getting water, as much water from our water source, our raw water source, we want to ensure that we have water stored up. And in some instances, we have millions of gallons, tank systems that have millions of gallons. So we could still continue to provide a certain amount of water, even if we have a little dry spell. Okay? The third one is to pressurize the water system. Okay, we want to maintain positive pressure. Okay, so we have positive pressure from elevated tanks. These are tanks that we use specifically for maintaining pressure. And some of these tanks, their capacity or the amount of water that they store might not be as high as other tanks, but that is because they are mainly there to provide an injection of pressure into the distribution system. Okay, so these are, and we have about 5 main different types of tanks: elevated storage reservoirs, standpipes, in-ground reservoirs, above-ground storage tanks, and hydropneumatic tanks. The hydropneumatic tanks, these are special tanks that provide system pressure. So these are tanks that specialize in providing pressure, and they do not have much storage capacity. Okay, so these are some of the things that is covered in the unit. Okay, next class, in our next session, we are going to be looking at, so I'm going to open up the next session later today. Okay, so let me see, is that a question? Okay, somebody's asking about the inside, whether the inside of valves have special anti-corrosion base. It depends on the material that the valve is made of. In a distribution system, very often, a lot of these valves are made out of metal, very thick metal. And the valves tend to last for a long period of time. I cannot tell you how long they will last for, because how long they last for depends on the usage. It depends on the conditions that is existing and so on. Okay, so I cannot really give you a time period for that. But most anything that is in the distribution system, we would consider the ability to withstand corrosion, especially if it's in the soil. We would consider the ability to withstand corrosion. However, a lot of valves end up in what we call valve boxes, where they are not necessarily in direct contact with the soil. A lot of them are in valve boxes. They are covered, so we have easy access to them. And as a consequence of that, corrosion might not be as big an issue as if that pipe were buried in, if the valve were in direct contact with the soil. Okay, how do we ensure storage water is not stagnant? Generally, even if we have water tanks that are storing water, we would not, it's not a case of just leaving the water tank there and then and we are not using from it. Remember that in most cases, the water tanks are generally filled from the top and they're emptied from the bottom. So what you have happening with a lot of water tanks is that using our systems, we basically control the amount of water that is in there. So usually what happens if you have what we call a Scada system, the Scada system is a system that allows us to control what's going on in the water system from a central point. And in that Scada system, we will have sensors. We will have sensors on most of our tanks that would allow water to be, when the tank is full, we stop fooling, then we use from the water, and then once the thing gets to a certain point, we start refilling. Now, most times you have an operator inside of some kind of office who is controlling the Scada system, and the Scada system would show him the various tanks that are available, the pumps, whether they're operating or not, and he can shut pumps on and off. He can see the water level in the tanks, and start pumping water to the tanks, close and open valves and that kind of stuff. So the water tends to move within a certain period of time from the tanks, and that water does not get stagnant. So stale water from a tank shouldn't be something, shouldn't be an issue. In addition to that, tank maintenance is something we have to discuss as well, where the tank is emptied out, the inside of the tank is cleaned. Okay, we check to see if the coating on the inside, if it's a metal tank, the coating on the inside, protective coating that protects it against corrosion, whether that is intact, and we make whatever repairs and what have you, and then we put the pump back into, we disinfect and put it back into operation. So stagnation should not be much of an issue with these tanks. And also, if we need to top up in terms of chlorine residual, if the chlorine residual may have dropped for whatever reason, we try to maintain a certain chlorine residual throughout the system, and that includes inside of the tank. And once we can maintain that residual, then we don't have an issue with stagnant water. Any other questions before I close? While I wait, let me remind you that your worksheets, your responses to the math worksheets are due on Tuesday by 9 a.m. Okay, on Tuesday by 9 a.m., your worksheets are due. So those of you who have not submitted, make sure you submit by that time. Once everybody has submitted, we will release an answer sheet, which would have worked answers to the questions on the worksheet. Okay, Mr. Daniel is adding, okay, Mr. Daniel is just adding a point here, which I think is very important. He's saying from a design point of view, your inlet, where the water, the extraction point should be opposite from the inlet. So where the water comes in should be opposite from where it goes out. Okay, so that would also help prevent stagnation. Okay, all right, that's Colin Douglas. Okay, let's discuss that in the WhatsApp group. Let's discuss that in the WhatsApp group, Colin. Okay, all right. So Mr. Daniel has just pointed out that he will deal with any math issues in the upcoming days. So if you have any issues that you would like him to if you want to have a one-on-one with him, for instance, then you could contact him either through the WhatsApp group to let him know so that he can deal with them. Okay, how regular should we chlorinate these tanks? It's not an issue of well, it's not an issue of having a regular period of time in which one of the things that we do in a distribution system is we monitor certain aspects of the water. And one of these is our chlorine residual. So we're doing monitoring and testing. So if when we do our monitoring and testing, we realize that our chlorine residual is lower or is way lower than it should be in a tank, then of course, we will have to do something about that to increase the residual in the tank. So based on our monitoring and testing, we would take actions. But it isn't that we have a schedule for going and chlorinate tanks or so on. That is not the case in most distribution systems, because the water in the tank should have a chlorine residual in it, provided that it does not remain without movement for a long period of time. The chlorine residual should be good. Okay, and Mr. Daniel just added something there which is important. Okay, thank you so much. Okay, very good. Okay, if there are no other questions, I am going to bring this class to a close. I want to remind you to post in the discussion forum any questions. We also have a WhatsApp group where you can get assistance with any technical issues or otherwise. Okay, so you have ways of reaching us, ways of solving your issues, and also another reminder that your submission for your math worksheets is due Tuesday, 9 a.m. So thank you so much. Enjoy the rest of your Saturday and the rest of your weekend, and continue to remain safe from everything, but also from COVID-19. All the best. Take care.
Okay.